Hi, I'm an old guy and I do maths. We're going to attempt to solve this inequality today. And this is a form which has caused a pupil or two of mine some puzzlement. It's on the surface probably easier than they would expect, but there's a puzzling aspect about this part of it. So let's get into this and see what we can do. So this is an inequality where we have an equal or less than sign, and that means that we're looking for defined points on the x-axis for a solution. So the solution could be 4 or 5. It won't be greater than or less than 4 or 5. It will be equal to or greater than 4 or 5. So just bear that in mind. We don't have to do any manipulation when we deal with this equation. We don't have to solve all of it. We have a potential solution here, which is x equals 3. Negative 3. That's 3, so this will be negative. What we really need to do is we really need to factorize this and see what we get. And this is where it gets interesting, because I think this is where the confusion comes in. Now, what factors of 5 add to 2? None. So we have two options when it comes to solving this thing. One is to complete the square. The other is to use the quadratic formula. I'm going to use the latter, the quadratic formula. So that is A, that is B, and that is C. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And here we have a, b, and c. So negative b, negative 2 plus or minus the square root of b squared, which is 4, minus 4 times 1, that's a 1 there, 1 times 5. And the astute amongst you will have noticed that we possibly have a problem here, but we'll come back to that. This is all over 2 times a, which is 2. Now, if I tidy this up, I get negative 2 plus or minus the square root of 4 minus 20. This is negative, so this thing has no solutions for x that are real. And that has some consequences. So if there are no real solutions, what that means is that this function, it's not that this function doesn't exist, it's not that it couldn't be graphed. It is that it does not touch the x-axis. So that has the following consequence for our graph, which is a cubic. It is x times x squared, so that gives us a cubic. And we have one point on the x-axis that this touches, and that is negative 3. Where does it touch the y-axis, out of interest? 3 times 5 at positive 15. And what this thing looks like is this. It's got a characteristic cubic form, but it has only one x-intercept, and that's at negative 3. So now we can answer the question. Where is this less than or equal to 0? Well, down here. All of these y values are either equal to or less than 0. And so our solution is that x has to be less than or equal to negative 3. It's actually a great deal simpler than it looks. But the key is not to be panicked by this. The minute you see a negative in this radical using the quadratic formula, you know that you're not dealing with real solutions for x, which means that, as I said, this part of the graph, this part of the function, is not something that has x coordinates, to put it, coordinates on the x-axis, to put it in terms that I think are readily understandable. So thank you very much for watching. That is how you do this, and I hope you found this useful. Thanks again. Don't forget to like and subscribe. Bye.